So, welcome back. We'll discuss this experiment 5, which is a 3-bit multiplier using gate level modeling. So 3-bit multiplier means we have here A to B we have to perform. Let's say A into B. So to perform this A into B, here A has got 3 bits and B has got 3 bits. So let us represent those 3 bits like this. A3 is just a minute. A2, A1, A0, 3 bits. B2, B1, B0. So now here we have to multiply bit by bit, right? So this B0 into A0. So I can write down this one. Now this B0 into A1. Now B0 into A2. So what is next? B1 into A0. Then this B1 into A1. Next, this B1 into A2. So what is next? This B2 into A0. B2, B2 into A1. Finally, we have this A2 into B2. So now what we have to do here? We have to add this. This A0, B0 will give us a product bit B0. This will give. To get this A1, B0, we need one AND gate here. And for this also one AND gate. But that AND gate will produce a bit. So let's call that bit as a Y0 here. And this is Y1. So now what we have to do is Y0 and Y1 we have to add. So if you add that, you will get sum, right? That sum we're calling it as a product bit P1. And the carry generated will go to the next stage. So here also same again, this A2 B0 needs to be given to one AND gate, which will produce a output, let us say Y2. And this one, A1, B1 will produce a output, let us say Y3. Now let us say this A0, B2 will produce a output Y. Now what we have to do? We have to add C1, Y2, Y3, Y4. So if we add all of this, then you get here product bit P2. And during this addition, you may get some carry. So we add C1, Y2, Y3. So you will get one carry out here. Okay. And then this C1, Y2, Y3 also will lead to some sum. That sum is added with Y4, and that Y, the sum of this, C1, Y2, Y3 will produce two things. One is sum and the other is carry. So carry is given here to the next stage. The sum will be added with this Y4 also. So that is what resulting to this product bit P2. And that sum when been added with Y4, it also may produce one another carry. So like that, from this stage, two carry may come. So if you add like this three bits together once, and then the sum is added with the Y4 once again. So then two carries will. So now here this seed to produce this A2B1, we need one AND gate. So let us call the output is Y5. Now to produce, this A1, B2 will produce a output Y6 if we give it to one AND gate. Because the A1 dot B2 means AND gate. Now here of same thing again, C2, C3, Y5 will be added. It will produce a carry out and sum. That sum is added with Y6. That will produce another sum that we are calling it as a product bit P3. And the carry generated is C1. Now, final stage, this A2, B2, we are giving it to one AND gate, it will produce a output Y7. Now, C4, C5, Y7 will be added. It will produce a product bit P4. Now, this also will produce a carry out, which will go to the next stage here. That is C6. There is no another bit here. So directly C6 is what the another product bit, final product bit, that is P1. So this is what the theory related to this 3-bit multiplier. Okay, using gate level means we have to implement this entirely using the primitives, Verilog primitives. So you got to know from here we need AND gate, and this is like 2-bit addition. One half adder is required here to implement this. So half adder is implemented using one XOR gate, one AND gate. So then this is going to produce a carry out. And here to implement this A2, B0, A1, B1, A0, B2, we need 3 AND gates. These 3 AND gates will produce corresponding outputs Y2, Y3, Y4. Now we have to add this C1, Y2, Y3 to add this here. We need one full adder. And this full adder will produce one carry out, which will go to the next stage. And the sum will be given to in the current stage with the Y4, we have to add that sum. So only 2 bits here. So we need one half adder here. So that half adder will produce a sum. That is, we are calling it as a P2. And it also will produce another carry, which is going to the next stage. In the next stage, we have this A2, B1 and A1, B2. So we have to produce the result of this A2 dot B1, that is Wi-Fi. We need one AND gate. To produce this A1, B2, we need one another AND gate, which will produce output Y6. So here again, C2, C3, Wi-Fi, we need one full adder. Full adder will generate a carry out, that is C4. And the sum is added with this Y6. Here 2 bits sum and Y6, we need one half adder. So that half adder will produce one sum. That is, we are calling it as a P3. And the carry generated is C. And in the last stage here, we have A2, B2. To implement this A2, B2, we need one AND gate. So the output is Y7. Now we have to add all of these 3 bits. So we need one full adder. Full adder produces a sum that sum we are calling it as a P4. Now finally, The carry generated out of that full adder is what this C6. There is no another bit here to add. So that C6 itself is a P5, that is product bit 5. So like that, let's develop the code for this now.